Okay, 5.3, day 1, square root function. We're going to graph the square root function today as our new parent function. So the parent function of the square root function is f of x equals square root of x. Okay, so I'm going to make a table to graph the parent function, then we're going to use the parent function after this. Okay, what should I pick? I'm going to pick 0, because I feel like that's really easy to square root. Okay, the square root of 0 is 0. Let's put it on our graph. Okay, pick another number that's easy to square root. 4. Okay, the square root of 4, 2. So 1, 2, 3, 4, 1, 2. What else? 1. The square root of 1 is 1. Okay, we have room for one more. So let's pick one more. Square root of 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay, we did not put any negatives in. Should we have put negatives in? No, because we cannot square root negatives. So our graph starts at 0, 0. And then it's going to go to the right, because I could plug in more numbers to the right. I could plug in any number, really, but I could also plug in 16 and stuff like that. So it's going to go like this. It goes this way. It's actually like half a parabola turns sideways. Okay, this is the square root function. This is its general shape. Okay, domain is what are the x values? The x values start at 0, and then they go to the positive values. They go to 1, they go to 4. They can be anything, really, on the right side. So the domain is x's have to be greater or equal to 0, because I can square root 0 and higher. The range is what are the y values? The y values start at 0, 0. Then they go up and up and up. So the range is going to be that y is greater or equal to 0. Okay, this is a square root function. We're going to use this square root function to graph stuff. Okay, which points am I going to use when I do this? I'm going to go 0, 0. I'm going to go 1, 1. And then the square root of 4 is 2, so I'm going to go 4, 2 most of the time. And normally I don't use 9, 3 unless it fits on my graph. Okay, now these ones are going to have transformations, though. Okay, so this one, what are we doing? We have a plus 1, so this is going to go up 1. That's my transformation, my translation. So let me go up 1. Okay, now I'm going to try to do my parent function. Remember my parent function. It starts here, right 1, up 1, right 4, up 2. Okay, so from this point, I'm going to go right 1, up 1. Okay, and then from that starting point again, the square root of 4 is 2. 1, 2, 3, 4, 1, 2. I'm going to put another dot up there. Should I do another dot? We can do another one. Oh, hold on. I'm off a little bit. 4, 1, 2, 3, 4, up 2. Okay, if we have room, the square root of 9 is 3. So from here I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. Okay, that one did fit. Okay, and then it's going to make that same shape we just made on the original one. So it starts up 1 and then it goes this way. And it does have an arrow. Okay, what's the domain on this? Domain is the x values. Okay, well, it starts at x equals 0, and it goes to 1, 4, 9. It keeps going to the right. So the x's are greater or equal to 0. What are the ranges? Well, the graph starts here. What does y equal here? Y is 1, and then it goes up. So the y values are greater or equal to 1. Okay, let's try another one. Okay, this is the square root of x plus 3. Since the x plus 3 is in the radical, it's like it's in parentheses, so it's going to go left 3. 1, 2, 3. Okay, and then I'm going to make the same pattern. I'm going to go 1, 1, because the square root of 1 is 1. What's the next easy square root? The square root of 4 is 2. 1, 2, 3, 4, 1, 2. Okay, if we have room, we can do square root of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. Okay, it's going to make that same shape. Okay, domain is the x values. This is where the graph starts. What's the x value here? -1, -2, -3. So it starts at -3, and then it goes to the right, which are the numbers that are bigger than -3. So x is greater or equal to -3. The range is the y values. This is where it starts. What's the y value here? 0. Okay, from the 0, does it go up or down? It goes up. So y is greater or equal to 0. Okay, can we do two translations? Let's try this. What is this? Left 2, down 3. Okay, we got that. Okay, now the trick is the pattern. Okay, square root of 1 is 1. So I'm going to start with that. Okay, the square root of 4 is 2. 1, 2, 3, 4, 2. If I have room, the square root of 9 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Okay, so it started left 2, down 3, and it's going to go to the right. Like this. Okay, my domain is my x value. So where does it start? It starts right here. The x value here is -2. So x is greater or equal to -2. Y values starts here. What's the y value here? -1, -2, -3. Greater or equal to -3. Okay, let's do one more. What is this? Right 2, up 1. Okay, that's where my square root function starts. Okay, square root of 1 is 1. The square root of 4 is 2. The square root of 9, 1, 2, 3, 4, 5, 6, 7. Square root of 9 doesn't fit anyways, but that's okay, because it's still going to make this shape and go to the right. Okay, domain x is, what's the x value here? 1, 2. X is greater or equal to 2. Range is the y values. The y value here is 1. Y is greater or equal to 1. Okay, now let's consider some other transformations that we have worked with in the past. So f of x equals -root x. That's going to reflect over the x-axis. Or the y is going to change signs. Okay, so what does this start? This normally starts at 0, 0. Okay, normally I do right 1, up 1. But since I'm reflecting over the x-axis, instead of going right 1, up 1, I'm going to go right 1, down 1. Okay, and then the square root of 4 is 2. 1, 2, 3, 4. But instead of going up 2, I'm going to go down 2. Okay, do I have room for 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. Instead of going up, I'm going to go down because I'm reflecting the x-axis. Okay, so it makes the same shape, but it's going to go this way. And it looks like the other side of the parabola. Okay, domain. X is greater or equal to 0, because I'm starting at x is 0 and going to the right. Okay, we're going to be careful on our range. Okay, the y starts at y is 0, but now it's going down. So the y's are actually less than or equal to 0 because they're negative. Okay, let's try another one. We're timesing 3. If I times 3, it gets bigger, so this is a vertical stretch by 3. Okay, I'm going to start at 0, 0. Okay, and then square root of 1 is 1. So I normally go here, but I want to go 3 times as high because I'm stretching vertically. So instead of going right 1, up 1, I need to go up 1 3 times. 1, 1, 1. Okay, now let's think about the next point because it's totally going to go off the page. Okay, the square root of 4 is 2. But I'm stretching 3 times, so I need to go up 2, 2, 2. It's going to be way up here, which is so high. Okay, so I can only fit 2 points in this case because my square root function is going to go up, 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 up. Okay, what's my domain? X is greater or equal to 0. And then the y direction, we're going up, so it's also greater or equal to 0. Okay, how about f of x equals 1/2 root x? Timesing half is going to shrink it. So this is a vertical shrink by half. But I still start at 0, 0. Okay, and then I normally go square root of 1 is 1, but I only want to go half up. So instead of going all the way to 1, I go halfway to 1. Okay, and then when the square root of 4 is 2, but instead of going all the way to 2, I only go halfway to 2. If I go halfway to 2, I only go to 1. It's going to be a little short. Can I do 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 does fit. The square root of 9 is 3. If I only go halfway to 3, I'm going 1.5. Okay, it's very squashed, but this is going to be my little square root. Okay, my domain, x is greater or equal to 0. My range, y is greater or equal to 0. Okay, let's try this one. This one's got 2 things. It's got the left 1 and it's got the vertical stretch of 2. Okay, and I normally write the stretch first, although with left and right it doesn't matter. So let's go left 1 though when we graph it. Okay, and then I'm going to do my transformations. I'm stretching by 2, so instead of going right 1, up 1, I'm going to go right 1, up 1 twice. Okay, the square root of 4 is 2. 1, 2, 3, 4 is up 2, but I want to stretch it by 2, so instead of going up 2, I go up 2, 2, I go up 4. Okay, I'm not going to bother with 9 because there's no way it's going to fit on the graph because I'm basically already at the top. So this is my tall square root function. And I got moved left 1. Okay, now my domain, well, it got moved left 1, so it's greater or equal to -1. And my y is 0 here, but it's going up, so it's going to be greater or equal to 0. Okay, last examples are just writing a transformed radical equation, which we are pretty good at. Okay, let G be a vertical shrink by factor of 1/6, followed by a translation 5 units left of the graph of f of x equals the square root of x. So this is going to be a square root. Okay, let's see. I want to shrink by 1/6, so I'm timesing by 1/6. This is a square root function, and I want it to go 5 units left, so x plus 5. Let's think about this. Vertical shrink of 1/6, translation 5 units left of the square root. Okay, I think we got all the pieces, so this will work. Okay, for B, given f of x equals root x, create a rule for G where f is vertically stretched by 2. Vertically stretched by 2. So I'm going to times 2. It's reflected across the x-axis, negative. And then it goes up 7. What was this function? Square root of x. So square root of x, up 7. And I think I got everything, but let's just double check. Okay, f is vertically stretched by 2, reflected across the x-axis, up 7. And this is a square root function. Okay, so I think we got it. Okay, one more. Given the function f of x equals square root of x, create a rule for g of x, where f of x is shifted up 5, okay, up 5, left 3, okay, oh, and vertically stretched by 2, and that was listed last, so I'm going to apply it last. So it looks like it's going to be 2. You don't distribute into a radical. Plus 2 times 5. Now we're at 10. And this was g of x. Okay, let me just double check that I got everything. Given the function f of x equals root x. Yes, I have a root. Create a rule for g of x. Yes. Where f of x is shifted up 5, left 3, and then vertically stretched by 2. And so I timesed it. Yes, and then I think I got everything.